If a function has one independent, if the function has not one independent, if the function is expressed as, can be expressed as such that the dependent variable is in terms of the dependent variable can be written in terms of the independent variable. Then such a function is called explicit function. Example. Let us say y is equal to x e to the power of x, right? So you know here that y is whatever value of x you take, you will get the value of y, isn't it? You take the value of x as 1, you get the value of y as e. Okay, you take the value of x as 1.5, you get another value, isn't it? So, uh, and clearly you see that y has been expressed in terms of x, right? You know you know that y is equal to so and so x, right? Such a function is called explicit function. Y is equal to sine x. So whatever functions we have dealt with till now, you must have seen that they are all explicit functions. Y is equal to something in x, right? Such functions are called explicit functions. We now come to the concept of implicit functions. Okay, suppose if a function of two or more variables, if a function of two or more variables is such that the dependent variable may not be written in terms of the independent variable. Then such a function is called an implicit function. Such a function is called an implicit function. Okay. So you have two kinds of functions, explicit functions, implicit functions. Examples of implicit functions. Suppose if I give you a function like say x cube plus 8xy plus y cube, fxy is equal to a function of two variables is written in this manner. Okay, fxy is equal to this. Then can you write x in terms of y or y in terms of x? You cannot write, right? You don't know which one is the dependent and which one is the independent variable, right? And you can make any variable dependent and any variable independent, depending on your choice. If you can write x in terms of y, then x becomes a dependent variable. If you can write y in terms of x, then y becomes the dependent variable. Okay. Such functions are called implicit functions, where you cannot write y is equal to something in x. Okay. So how to differentiate now? Here we'll see how to differentiate these kind of functions. That is, fxy is equal to x cube plus 3xy plus y cube. How to differentiate when functions cannot be written explicitly? That is, they cannot be written as y is equal to something in x. How to deal with, how to differentiate such functions? So differentiation. Now we start differentiation of implicit function. Now in differentiation of implicit functions, your work uh, 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 will greatly be reduced while differentiating a lot of functions. Okay, a lot of big functions can be differentiated very easily with the help of implicit functions. So we will see how this is a very useful method of differentiation. Okay, let us take the following examples uh, to illustrate differentiation of implicit functions. So differentiate, let's say find dy dx. Find dy dx. When I write dy dx, it means what? It means y is the dependent variable and x is the independent variable, right? So find dy dx if first question is x cube plus y cube equal to 3axy. And second one, I'll give just two questions here. Okay, x square plus y square whole square is equal to xy. So let's see. So we start with the given function, given x cube plus y cube is equal to 3axy. Okay. Now we differentiate both sides with respect to x. Differentiating both sides with respect to x. If I'm differentiating with respect, what does differentiating with respect to x mean? It means I must have dx in the denominator. That is, x is the I'm making x as the independent variable, right? So I'm going to differentiate now. So I have ddx of x cube. So I differentiate the left hand side and I differentiate the right hand side also. Okay. Now see, you can distribute this differentiation over x cube and y cube, which you do normally. And this 3a is a constant, so it can come out. Okay. Now see, in the next step, this is very interesting here. See, I have x here, right? I'm differentiating x cube here with respect to x. So this is something that I can do. So this is 3x square. This is okay. But here I have a y, which is a dependent variable, and I'm differentiating it with respect to x. Y is not a constant, remember, y is also a variable. Okay, y is a dependent variable, and I want to differentiate it with respect to x. So how will I differentiate? First, what I will do is I will differentiate this variable y with respect to y. This function I will differentiate with respect to y. So if I differentiate y cube, how much will I get? 3y square, right? Not only that, but after multiplying by 3, after having differentiated by 3y square, I will multiply this by the derivative of y. That is, I will differentiate y with respect to x. Understood? This is the most important step here. After differentiating with respect to y, the function, after differentiating the function with respect to y, I will differentiate the variable with respect to y. Okay? I hope this is clear. So this is into 3a, and here you differentiate this by u into v rule. That is, this is your u, this is your v. So x, first function, ddx of y plus y ddx of x. So therefore you have 3x square plus 3y square. ddx of y is dy dx is equal to 3a x dy dx plus y. Okay. So now we can find out dy dx. Take dy dx all together and take dy dx common. Okay, so you can take 3 dy dx common. What do you get? Y square minus ax. And from here, you can take 3 common. You get ay minus x square. So what happens? These two 3's, they get cancelled here. You simply get dy dx is equal to ay minus x square divided by y square minus ax. Okay, and that is your answer. Let us see the next one. X square plus y square whole square is equal to xy. How to differentiate this? Okay, same way. We'll first say differentiating both sides with respect to x. Now, I'm showing you all this step by step only for these two sums. After this, I'll be doing directly. Okay. So left hand side you differentiate and you differentiate the right hand side. Okay. So here, first of all, I will differentiate the power. Nx to the power of n minus 1. So x square plus y square to the power of 2 minus 1. Okay. Into the ddx of whatever is within the power. Right. And this you differentiate by u into v rule. You have x ddx of y plus y ddx of x. Next step, twice x square plus y square into, now ddx of x square is how much? Let's distribute this over all this. This is x dy dx plus y. And ddx x square is 2x. And ddx y square is, how will I differentiate y with respect to x? First differentiate y square with respect to y to get 2y. And then differentiate y with respect to x.
Divide.
Okay. So I'm doing this step by step as I told you. In the next step, and then after this, all these sums, these two sums I will be doing directly. Okay. Is equal to x dy dx plus y. So twice x square plus y square into, from here also you take 2 common, twice x plus y dy dx is equal to x dy dx plus y. So now here you have 2 and 2, multiply them together, 4 x square plus y square, and you multiply everything together. That is 4x square, you get 4x into x square plus y square. Okay, plus 2y x square plus y square dy dx is equal to x dy dx plus y. Now you take the dy dx together. 2y is equal to y minus 4x into x square plus y square. That means now you can take dy dx common. 2y x square plus y square minus x dy dx is equal to y minus 4x into x square plus y square. And so therefore you have dy dx is equal to y minus 4x to x square plus y square divided by 2y x square plus y square minus x. That's it. That's the value of dy dx. Okay, and this is how you differentiate. Remember, when differentiating any function of y, you will first differentiate it with respect to y and then multiply it with dy dx. That's the bottom rule. And let's do the next one. Problem. Question is, if y log x is equal to x minus y, prove that dy dx is equal to log x by 1 plus log x whole square. Okay. See here, we start with the given function y log x is equal to x minus y. Okay. Now we differentiate both sides with respect to x. Differentiating both sides with respect to x. Okay. ddx of y log x is ddx x minus y. Y log x you will differentiate by u into v rule. So you have y ddx log x plus log x into differentiation of y, right? Which is simply dy dx. Differentiation of y with respect to x is equal to ddx x minus ddx of y, means dy dx. That's it. So ddx of this is ddx of log x is how much? 1 by x. So get y by x plus log x you write as it is, dy dx. ddx x is 1 minus dy dx. Now you take all the dy dx together. So you get log x dy dx plus dy dx equal to 1 minus y by x. So now you take dy dx common, and here you can take the LCM, x minus y by x, and therefore now you divide both sides by 1 plus log x to get x minus y by x into 1 plus log x. And that is, I think, what you had to prove, right? Let's check. 1 plus dy dx is 1 plus log x whole square. Okay. 1 plus log x whole square. Okay. So I think I have to put a value of y also somewhere here. There has to be a y. Okay, here is the y. When I have from this step, if you see, y by x plus log x dy dx is equal to 1 minus dy dx. Okay, when I'm taking the dy dx here, you get everything in terms of x as 1 plus x by 1 plus log x. Okay, now this, the same thing, you put it here. So hence dy dx is equal to x minus y. Y here is okay. So now you can take your x common from the numerator. What do you get? 1 minus 1 by 1 plus 1 minus log x. 1 minus 1 by 1 plus log x divided by 1 plus log x. Now you take the and you have an x also here, so that these two x's will cancel. So now if you take the LCM in the numerator, you will get your 1 plus log x minus 1 divided by 1 plus log x whole square. Okay, so we have got our answer. So which is equal to log x by 1 plus log x whole square. That's it. Okay, and that is proved. Next one. Number 18 from the textbook, my textbook. There should be a different problem in your textbook. Given here, so find dy dx if, find dy dx if x log y plus y log x is equal to 5. We start with the given function x log y plus y log x is equal to 5. Differentiate both sides with respect to x. Differentiating both sides with respect to x, we get ddx x log y plus y log x is equal to ddx of 5, which is 0. Now you will differentiate both of them separately So ddx x log y plus ddx y log x is equal to 0. Now x log y you're differentiating, you will differentiate by v rule. So x ddx log y plus log y ddx of x, right? This is the entire breakup plus y ddx log x plus log x dy dx is equal to 0. Now let's differentiate this. X ddx of log y. How will I differentiate the log y with respect to x? Yeah, I have a function of y and I'm differentiating with respect to x. As I told you, first you will differentiate with respect to y to get 1 by y. Derivative of log y is 1 by y. If you're differentiating with respect to y, and after differentiating with respect to y, you will differentiate the variable dy dx plus, again here you have log y, and ddx of x you know is simply 1. So you simply have a log y. You don't have to write anything there. Plus log y plus y. Now ddx of log x you know is 1 by x. Okay. Plus, and you have a log x dy dx. That's okay. So now you take the dy dx together. If you take dy dx together, here you have dy dx, here you have dy dx. You take them together, you get x by y plus log x dy dx plus y by x plus log y is equal to 0. Okay. So that means now you divide both sides by x by y plus log x to get dy dx is equal to y by x plus log y divided by x by y plus log x. Okay. Now you can take the LCM. Y plus x log y divided by x plus y log x divided by y. So that means what will it become? If you have, that means this will become y into y plus x log y divided by x into x plus y log x, and that is the value of dy dx. Okay. Clear? Any question? This should be a minus sign here because there's a plus sign. I'm taking this on the other side. There has to be a minus sign here. So therefore, ultimately also here you will get a minus sign. That's it. No question?
No, sir.
Okay. So I'll stop here. Okay. I'll do 2 more problems from implicit functions next class.